Welcome to our session on conditions. One of the most important statements in every programming language is the if statement. So beside of being able to loop through something to execute parts of a code again and again and again, it's very important to be able to branch your code. So to set up a conditional block, that's really a fundamental principle in writing software. In C#, the if statement is very simple to use. It basically needs a Boolean result, which is either true or false, to create a branch either in this or in that direction. How to create a if condition we will see in our Rhino Grasshopper example. Please go to our basic concepts file, open it in Grasshopper and right click on example number 6 and enable it. What you see is this wonderful outcome 6 equals to 6 is true. If you open the code window, you see what's the magical code behind this outcome. So that's our first very basic if condition example. In the beginning we define or we declare a value. By the way, it's not very intelligent to call a variable value, because as you see this is marked in blue, and blue means this is a keyword reserved by the programming language. Therefore it's better to rename it to my value, for example, or to something else, but then we have to change it in the following as well, and then it still works, creates the same outcome, but it's not using a keyword from C#. Okay, what happens here is we assign 12.0 divided by 2 to my variable. So here you see you can also assign the result of a mathematical operation to a variable. And now we look into a comparison. We ask if my value not equals to 6. If this is true, then I print this line of code. If it's not true, I print that line of code. Okay, from the beginning. First of all, this exclamation mark equals to means not, as you already may have guessed. So this is a not logical operator. So means if my variable is anything else than 6, I can print that my variable, and here with this syntax I can convert the variable to a string. And the string can be combined with additional parts of a string. So I say I convert 6 to the string 6, and I add here this part, which is a string again. So if it's not 6, then I say it's not true, means it's false. And else means if my variable is not 6, means it is 6, then I can print 6 equals to 6 is true. So this is what we see here. Yeah? We can also write it the other way around, what I will do in a minute, but before I do this I want to show you one effect that we have by using a double variable, which is a floating point variable, as we have introduced in the beginning. Except we use 2 integer values. So if we have this form without here or there having a floating point value, the result of this computation is converted to an integer value, if you have only integer values in your mathematical formula, which means 13 divided by 2 would be 6.5, but since it's converted to an integer value, the 0.5 is cut and the result is 6, which we can see if you run the code. You see it's still true. Should be false. If I say it's 13.0 and I run it, then you see, now it's converted to a double because I have here a floating point value and it's now the correct result. This is sometimes a source of a bug that may be difficult to find. You can also convert this to a floating point value, same effect. One of them have to be floating point. Okay, now just to show you that you can also turn it around, maybe easier to read, means if my value equals to 6, I want to say that it is 6 and with this true, and if it is not 6 means else it's false. By the way, if you want to compare a value with another one, you need to have 2 equals. Otherwise you would assign 6 to my value. So having only 1 means assigning the right part to a variable, to the left part. Having 2 equals means comparing this with this value. Okay, if you run it again, then the result is still the same, nothing has changed. If you convert it back to 12, we have 6 equals to 6. Now we end here. And what we can do as well is we can extend, now we have 2 branches of our code, but we can have many more, as many as we want. Therefore, let's just copy this part and say else if my variable equals to 7, then I say 7 is true. Just for having a quick example, if I run it, nothing's changing, but if I increase this value to 14, then you see the code goes to this position. 14 by 2 is 7, is not 6, so this is not executed. Then I call else, so if it's not 6, then else, maybe if, so maybe it's something different. Else if my value equals to 7, then I execute this one. And if nothing is true, for example like this, then I end up with my else condition. It's false. So you can have as many else if questions or branches as you like. There is no restriction. There is an additional syntax, additional structure that you can use, and this is the case keyword, which simplifies the usage of many possibilities, many branches that you can execute in your code. But I don't introduce this to you here in the beginning because that's a more specialized construct which you can look up on your own in case you may have a more complicated scenario or if you find it somewhere in an example. So just remember case, if you read somewhere case as a keyword, that's more or less the same as an if, else, if condition. Okay, so I mentioned that we may look back to our functions example, so enable example number 5 and open the code, and let's look into our example where we have had this nice function where we can send this value to it. Then it's rotating, so you remember it from the last session. Now we have had here this deactivated part of a code where we create a circle, and we create a circle if something is true. So what do? We create a circle which is at the same location as our rectangles, And here we use the rectangle to put it into my curve variable, not a circle. But if the I iterator variable or the K iterator variable equals to 2, I override the my curve variable with my circle, which I convert to a NURBS curve. So then I override it with the circle that I just defined here. But only if these two iterator variables equals to 2. So what happens? Ta-da! Here I change at the second column and the second row, respectively the third, because we start with 0, so 0, 1, 2. I change it to a circle, which has the center point. Here I use the corner. We could also use the center of, for example, the rectangle that we've created in before. Then I would have it in the middle, which looks better. So here you see another logical operator, that's the OR operator. Means this or this needs to be true, then the if condition is true in total. We can also write it in this form. Then the only difference is that the compiler looks at this part, and if this is already false, then it don't look at this part, because it wouldn't make sense. It already decided. What you can do as well is you can write an AND, and this means the compiler executes your code only if I equals to 2 and k equals to 2, and it has to be true in total, so both have to be true. So you know it from logic. If one is not true, then the whole expression is not true. But in this case, I and k is true only here, so we have a circle only in the center of our grid. The same is true for the AND logic operator. If you find two AND beside each others, this means it asks first to the left side if this is true. If this is already false, it would not execute this part. In our case, it doesn't matter because it's so simple, but if you have a very complex decision here, then it may make sense to write two ANDs. So now you have seen how to use the if condition, how to branch your code into this or that part. You can have, of course, complex functions that you call in the individual branches to run your code into a completely different direction, to make something completely different. So it's a kind of a decision that you can make in your code, which you can use for your own purpose. Please take the examples that I provided you. As always, you only learn it when you use it. Please experiment with it, make your own explorations and your own exercises. Enjoy playing around with the code.